Ladies and gentlemen, welcome to Friday, and I'm going to be your host, Scott Smith. I'm going to be teaching you 4.2 relationships with representing relationships. I'm going to be guiding you through these notes. The reason that I'm doing it like this is because there's a whole lot of reading that I'm going to do, and I don't think you guys want to hear my nasally voice. Just read through the whole thing and everything, so you can bounce around this video as much as you'd like after we have already seen each other and checked in. So I'm going to turn off my video and I'm going to share my screen. Here we go. Okay. These notes were created by Mrs. Bodog, brought to you by Mr. Smith. 4.2 notes, representing relationships. Because there's not a whole lot of room, if you printed this out, I'm going to be going over here for writing these definitions. So we have slope-intercept form. The definition of slope-intercept form is an equation written in the form of, let's change the color, y equals mx plus b. And, see ya. The y-intercept is b in the mx plus b. Actually, I can change that color. In the mx plus b. And it will be a number that isn't multiplied by something. So it's not multiplied by anything. And it also is also the let's see here. And when we get to graphing, I kind of put the definition within the definition there, but the y-intercept is the b in the slope-intercept form of y equals mx plus b. It will be a number that isn't multiplied by anything, and when graphing is done, when graphing is the y-intercept, I guess a comma right here as well. Now the slope is m in y equals, should change that color. M in y equals mx plus b of the slope-intercept form. And it is the item that is multiplied by something. And I say something because it changes with every question in this. If you guys remember your vocab from last year or early this year, it is the coefficient. The coefficient is the number that is connected to a variable. So let's do some examples. Dominic is signing up for a gym membership, with a one-time fee. So whenever they say a one-time fee or things like that, that's going to be indicative of the B of your slope-intercept form. And then a monthly fee to remain a member. The monthly fee is $50. The one-time fee is $150. So the one-time fee does not change. So that's not being multiplied by anything. Write an equation for C in terms of T, representing the total cost of the gym membership in T months. So what I'm going to do is, I know that I have to have 50 being multiplied by something, and it's going to be multiplied by T months because it's $50 a month. So it's going to be 50T, and then I have to add what it cost at the very beginning. So we're finding out what it's going to cost in general at any given time to be a member of that gym. So whenever we're looking through these, we have to pick out, okay, what's the constant? It's going to be $150 regardless. And then what is being multiplied by the variable, and the variable here is T, which is the time in months. After a baby was born, she began to gain weight at a rate of 2 pounds per month. I'm going to go ahead and I'm going to highlight this for you, because whenever you see 2 pounds per month, you know right away that that is going to be the slope. That's going to be the M, which was right here in this one. Because remember, we are always going to be doing this form, y equals mx plus b. And the things that we're going to be finding is the m and the b. The weight of the baby at birth was 8 pounds. Write an equation for W in terms of T, representing weight in pounds of the newborn baby T months after birth. So we know that it's 2 pounds per month, 2T for time. And then they weighed 8 pounds at the very beginning, so that's always going to stay the same. Michaela was given a box of assorted chocolates on her birthday. Each night, Michaela treated herself to 2 chocolates. There were originally 12 chocolates in the box. Write an equation for C in terms of T, representing the number of chocolates remaining in the box T days after Michaela's birthday. Now this one here, we are having a reduction. We're having a reduction in the amount of the constant. The constant is right here. We started with 12 chocolates. So if I were doing mx plus b, the b is going to be the constant, which is 12. But the thing is, we're reducing from b, we're reducing from the constant, and it said that we have 2 chocolates, 2t, but we're reducing by 2. We're reducing by 2. You could write it like this: we're reducing 2 for each day plus the 12. Another way that you could see this written is C equals 12 minus 2t. So the t there is each day. So the t there is each day, and we're reducing by 2 chocolates each day. Now these two here are actually the same thing, but I want you guys to use the form of y equals mx plus b, and they're just substituting in there. It's not y, they're using c. It's not x, they're using t. So they're using t here. So we found that we are reducing, which is subtraction, by 2 for each day. That's coming from the 12 chocolates that were originally available. Those are probably the harder questions on it. There's a couple of the questions on the homework for you guys today on that. Jace needs to lease out a music studio to record his new album. The studio charges an initial studio use fee of $200 plus an hourly fee of $100. Why did I do that? Apparently that is stuck there. Okay. Write an equation for P in terms of T, representing the amount of money Jace would have to pay to use the studio for T hours. So I'm going to highlight what we have here. So we have the constant, no matter what, we have a studio use fee of $200. So that's going to be my y-intercept, or B as it was written up there. So I have $200 plus $200. And an hourly fee. An hourly fee represents that, represents that it's going to be a situation where you have the multiply, however many hours you're there is going to be $100, and that's the unknown. Therefore, that's going to be our variable. So I have 100 of t, which is time. In this situation, it's hours. So we have 100t plus 200. At the end of a snowstorm, Elijah saw there was a lot of snow in his front yard. The temperature increased and the snow began to melt. So if something is melting, you can start to figure out or start to realize we're going to have a subtraction situation here. There was a depth of 18 inches of snow. So this one right here, 18 inches of snow, that's going to be our constant. That's going to be our y-intercept. That is going to be our b in y equals mx plus b. Storm, okay. So 18 inches of snow on the lawn when the storm ended, and it started melting at a rate of 1.5 inches per hour. So right there, when something is being multiplied, we know that that is going to be our slope or our m. So now we have taken care of b, we've taken care of m. So let's find out the parameters. Write an equation for s in terms of t, representing the depth of the snow in Elijah's lawn in inches. T hours after the snow stopped falling. So we had 18 inches of snow. It's reducing at 1.5 inches per hour. So that's one way you could write it. If we wanted to keep it closer to the slope intercept form for when we start to graph these, I could have a negative 1.5 t plus 18. And the reason I'm able to change that is because this is a positive 18, hence the plus 18. And whenever you have a subtraction of something, it's called the additive inverse. You can just add the opposite, the same way that 1 plus 2 is equal to 3. But let's do 2 minus 1 is equal to 1. But if I switch these around, negative 1 plus 2 is equal to 1 as well. That's the reason that we're able to switch these around. Maya needs to lease out a music studio to record her new album. Awesome. The studio charges an initial studio use fee plus an hourly fee for each hour in the studio. The total amount of money Maya would have to pay to use the studio in t hours can be determined by the equation P equals 50t plus 100. What is the y-intercept? So the y-intercept, remember, is the b. What is the y-intercept of the equation, and what is its interpretation in the context of the problem? So if I wanted to figure out what is the y-intercept, I have to recognize that that is going to be the constant there. So the y-intercept is 100, which represents which of the following? The total number of hours Maya used the studio. Okay, no, because this is the total number of hours that she's using the studio. That's T. The initial fee for using the studio, that's right, because that's what it told us. The total price of using the studio for the day, no, because that's P. No, it isn't. For the day, that would be $50. So that would be 50. No, it isn't. That'd be just T. The additional price per hour using the studio, no, because that's 50. So the correct answer would be the initial fee for using the studio. The weight in pounds of newborn baby T months after the birth can be modeled by the equation W equals 11 plus 2T. Now this is a little bit different of an order. They're having Y equals mx plus b, but you can also do, because of the additive property, b plus mx. Ooh. What time is it? 35. Okay, we're good. Good. 10 minutes. What is the y-intercept of the equation, and what is its interpretation in context to the problem? So the y-intercept, if you remember, is b. So it's 11. Go away. So we have 11. So is that the total weight of the baby? No, because that's what W represents. Is it the number of pounds the baby gains per week? No, because that would be 2. The number of pounds a baby gains per month? Oh, I see what they did there. There's nothing that talks about how much they gain a week. That'll be 2. The weight of the baby at birth, yes, it is 11. Because it tells us right here as being the initial data. Carter is going to use a computer at the internet cafe. An internet cafe is, I don't even know if they exist anymore, but before so many people had so many devices and internet access, it was like literally a coffee shop with a bunch of computers in it. So just imagine a place that looks like a computer lab where people would go in and pay money to access the internet. The cafe charges an initial fee to use a computer, and then an additional price per minute of usage. An equation representing the total cost of using a computer for t minutes at the internet cafe is given by C equals 9 plus 0.70 t, so that's the 70 cents. What is the slope of the equation, and what is its interpretation of the context of the question? So remember, y equals mx plus b. So we're looking for the slope, and the slope is m. So we know that the slope is 0.70 or 7/10. What does it represent? The additional charge per minute, the number of minutes the computer is used, and the total charge of the use of the computer? No, because that's $9, the initial fee. The total charge, no, that's actually C. The initial charge of use of the computer, no, that's $9. The number of minutes the computer was used, that's going to be T. And the additional charge per minute, that's going to be 0.70. So the correct answer for this one would be the additional charge per minute. And lastly, Kayla is moving to and must rent a truck. There is an initial charge for the rental plus a fee per mile driven. So we have per mile driven. So that means that that's going to be right there. The total cost of renting a truck can be modeled by the equation C equals 30 plus 2.50 m, where m is the number of miles driven. What is the slope of the equation? So we remember that in y equals mx plus b, this is the slope. And because 2.5 represents that, even though it's written like this, we know that 2.50 is going to be the slope. And because it's being multiplied by something, it is a coefficient. So we have to see, is it the initial fee to rent the truck? No, because the initial fee is $30. The cost per mile that Kayla drives, okay, that's $2.50. The total cost of renting the truck per day, that's going to be C. The total number of miles driven, that's going to be M. So which one of these matches up with that? Well, thanks for asking. It's going to be the total cost per mile that Kayla drives. Now, I don't expect you to write the 32.50, C and M. I'm just doing that for demonstrative reasons. So with that said, love you guys. Have a great weekend. And stay safe.